we are going to step it up a gear in our next code, which is looking at something called the transposition cipher, which is going to involve a little bit more maths and is more complex than any of the codes that we've looked at so far. So what's this all about? Well, the transposition cipher is based on factors and multiples. So for instance, we need to know the difference between factors. So for instance, if we look at 8 factors of 8 would be 2 and 4, 2 times 4 equals 8, etc. Whereas multiples of 8 would be anything that we can divide by 8, so 8, 16, 24, etc. So what you're going to do is write out a code word or phrase or whatever you want, just in plain text. And then you're going to remove the spaces, put all the letters together, and count the number of letters. Now, if necessary, you might need to add extra letters to make sure you end up with a number which have lots of factors. So, for instance, if you had 23 letters, 23 obviously is a prime number, so it doesn't have very many factors. So what you do is you just put like an X on the end or something, and then you have 24 letters, and obviously there's lots of factors, and we'll see why that's relevant in a minute. So let's have a look at an example. So suppose this is the phrase that you want to encode. So who will discover a vaccine? The first step then is to remove the spaces. So we end up with something like this, and then you need to count the number of letters. So you can see here that there's actually 24 letters, so we don't need to add any X's on the end because 24 gives us lots of different factor pairs. 12 times 2, 8 times 3, 24 times 1, etc. So what you're going to do then is choose a pair of factors to use as the basis of your table. So we've got 24. Now I'm going to choose a table which is 8 by 3 because 8 times 3 gives you 24. So what you're going to do is write out a table, so 8 by 3, and then you're going to take the message and actually populate the table. So as you're going along. So when you're encoding, you're going to do your 8 by 3 table and go along. So you're writing the message along in this direction. You can see here as we go along, who will discover a vaccine? So you're reading it along, okay? Makes sense so far. To encode it, what you do then is you go down the columns vertically. So your message, as you start to encode it, would not make sense to anyone. So you can see here that it's going to start WIV. And in fact, if we continue, we're going to end up with this, which to all intents and purposes looks like complete gobbledygook. So unless you understand this code, you can't decipher it. So fine, that's how we go about encoding. But obviously in this task, your challenge is to decode the messages that have been intercepted by the guys at GCHQ. So let's have a look then how we do the reverse. Here is an encoded message. The question here is, how can we intercept this? How can we decipher it to try and make sense of it? So, well, the process here is in effect the inverse. So you need to, first of all, count the number of letters, and hopefully you can see that there are 16 letters there. And then there's a bit of trial and error in here because we don't know which factor combination to use. We could have 16 and 1, or we could have 4 and 4, or 2 and 8. So we just need to choose one to start off with, and it might be the right one, or it might not, in which case we need to do it again. And we'll know if it's the correct one because we'll end up with coherent English. Words will make sense. So we're going to try a 4 by 4 grid. Now, this time, what you need to do is, as you're going along, you need to actually enter the information, the letters, but going down vertically. So in this column, we're going to enter J, and then we're going down the columns. So remember when we were encoding, we're going horizontally. If we're decoding, we're going to go down vertically. So all I'm doing is just taking these first 4 letters here, and then I'm entering them vertically. And then similarly, I would enter this. Now, what you can do is, as you're going along, is you should start to see words building up. Now, if we finish the rest of it, you can now see, if I read along to encode it, that I've got James, so that's my first word, B-O-N-D, so James Bond, that's my second word, is a spy. So that's how we decipher code. So for a bit more of a challenge, have a look at this. We have got this horrible message here. Now, if you came across that, you would find that, or most people would find that very difficult to decipher. But hopefully from what we've just said, you can have a look at that. So just try and have a go at that by yourself, and then we'll go through it. So for this, the first thing to do is to count the number of letters. So you can see that in total there are 48 letters. So you need to think of the factor pairs of 48. So we could have 24 and 2, or 12 and 4, 48 and 1. And again, you just need to try them. So you can see here that the first one that I tried was a 12 by 4 grid. So again, I've written 12 by 4, and then I've just gone down the columns. So here you can see I've got NNOG, and I've populated that going down vertically. And then the next 4 letters, ODMO, I've gone down vertically. And again, to decipher this then, I just need to try and read across the columns and make sense of the words. So now, run, along, and don't get into mischief. I am going out. So as you can see, this one can really be quite tricky, especially with long numbers where you have lots of factors and multiples. But you completed this stage of the training, and the next stage is to go on and have a look at something called frequency analysis, where you have an opportunity to use some English skills as well as maths.